Okay, so looking at number 9, maybe the first thing that we can do is subtract the 4 cosine from the 10 cosine and add the 4 to this side. That'll give us 6 cosine x equals 4, right? So you divide by 6 and reduce, and that's 2/3, right? Now look, we're trying to get x alone. So what you want to do now is you want to take the cosine inverse. I should have written it with more space. Take the cosine inverse of both sides, because cosine inverse and cosine knock out, and then cosine inverse knocks out cosine, so it's just x. And then cosine inverse of 2/3 on a calculator, it says about 48.18. So x is about I'm gonna call it 48.2 degrees. And you know what, look, a problem like this, it actually has 2 answers. Let me tell you why. Let me draw the unit circle. Now, look here. Let me go back to, before I took the cosine inverse, the problem said something like this. It said something like that. And you know what, let me write this down. 2/3 is the same as 0.67, roughly. So think of it like this. X is an angle. And then remember that on the unit circle, cosine is the x coordinate. So I want an angle where the x coordinate is 0.67. And 48.2 degrees works, because look, 48.2 degrees, that's about 48.2 degrees. So this point here, the x coordinate there is 2/3. And that makes sense because this point, to get up here, you have to move to the right and you have to go up. But you know what? Look, instead of going up, what if you went down? You see this point there? This guy's also good because the x coordinate here is also 2/3. Because how do you go from the middle to there? You have to go to the right, 0.67. And that's what you want the x coordinate to be. Cosine is the x coordinate. You want the x coordinate to be about 0.67. Boom, right here. See, if I move to the right, that's 0.67. Now, whether you go up or down is irrelevant because both of these points have an x coordinate of 2/3, which is 0.67. So what I'm trying to say is that 48.2 is not the only angle that works. This one works also, watch. Boom, you see that? That also works. This large angle that I'm drawing, this large angle is money because this large angle takes you to this point. And the x coordinate of that point is about 0.67, 2/3. So, but the question is, how do I find this angle? Well, look, this angle is almost 360, but it's a little bit shy. And it's actually 48.2 degrees shy of 360. So basically, go 360 minus 48.2, and that's about 311.8. And that's how, for a question like this, you get those 2 answers. So these are the 2 final answers. And notice that both of these angles are between 0 and 360, like the directions want. So that's it for number 9. Now looking at number 11, notice that we have sine squared and cosine squared. But a quick FYI, remember that these are facts from like a cheat sheet. Remember that this is one of those identities. Sine squared plus cosine squared equals 1. What if you subtract cosine to this side? If you do that, it'll say sine squared equals 1 minus cosine squared. So anywhere you see sine squared, you can replace it with this bubble, 1 minus cosine squared. And that's the substitution that I want to use right here. So look, I'm going to keep the 6. But instead of sine squared, I'm going to write down 1 minus cosine squared. 1 minus cosine squared. And then everybody else stays the same. Now, what was the point of even doing that? The point of doing that is because before it was sine cosine. Now it's cosine squared. So like we have some like terms, yeah? We have some like terms. I distribute 6, that's what I did. Now 6 and 1, that's 7. Negative 6 cosine squared minus 1 cosine squared is negative 7 cosine squared equals 2. Let me subtract 7 from there. And then after that, let me divide both sides by negative 7. So that cosine squared equals 5 over 7. And now if I square root both sides, I get cosine x equals plus or minus the square root of 5 over 7. And let's break this up into 2 cases. So cosine could be either that or cosine could be that, because the square root, when I did a square root here, the square root, that created a plus or minus. Now, I don't like that number. Let me turn that into a decimal. So this is kind of like the one before, where here, cosine is the x-coordinate. You want the x-coordinate to be 0.85. So on a unit circle, an x-coordinate of 0.85, well, 0.85 is positive, which means you have to go to the right. So this point here is probably good because the x-coordinate is 0.85. Now the question is, how much of an angle is that? Well, that's when you go cosine inverse of both sides. So you go cosine inverse of 0.85, roughly speaking, and it says about 31.8 degrees. So x is about 31.8 degrees, but then do the trick from before, where you go 360 minus 31.8 degrees, and that's about 328.2. Now, these two answers came from this equation. What about this equation? This one, you want cosine the x-coordinate to be negative that much. So this guy here, this point, goes with this answer. And the one that's directly beneath it, this one, goes with this answer. But now I want the same number, 0.85, but I want it to be a negative, which means that I want this one and I want that one. So how much is this angle here, right? How much is that one there? Well, what I want you to see is that this one here in blue, that one in blue, that guy was about 31.8, right? What I want is this one, and that is close to 180, but it's a little bit shy of 180. Specifically, it's 31.8 degrees shy of 180. So you got to go 180 minus 31.8. And that's about 148.2. So about 148.2. And that one is for this guy. And then the last one is this one here. But notice that this guy, it's more than 180. And it's actually this little guy above 180, which is the 31.8. So for the last answer, you go 180 plus the 31.8, and that's about 211.8. So this exercise, it illustrated the techniques that you want to use, but the rounding that I used may have been off. I don't know what the directions were specifically, but this number 11, it had 4 answers. And notice that all 4 answers respected between 0 and 360.